So this video discusses about solving the logarithmic equations simultaneously. Let's say if we have a 6 log, let's say 3 of x, and the minus 2, let's say log 3 of y, and which is equal to 7. And let's say that is equation 1. And let's say we have the another equation which is log should be 3 of x, that is minus 4 log, let's say 3 of y, and there should be that, which is equal to 9. And let's say this is an equation 2. Now, as you can see it here, we have these as the simultaneous equations, but we cannot solve the way they are because they are in complex form. So we should have to express them in a simplest form. So each equation will be expressed in a simplest form. And mind you, we have actually 3 methods of solving simultaneous equations. We have what we call as the substitution method, we have a elimination method, and also we have what we call as the graph method. But in all those cases, we need to express these equations in a simplest form first. So how should we have that one? So in this case, let's go for the first equation. So say in the first equation, that is let me use the symbol here. In the first equation, so that is in the first equation, how should we have to express the first equation in the simplest form? So in this case, we have 6 log 3 of x, and mind you, make sure that you understand about the laws of logarithms. Those are the things that will be used in this video, and also some of the things are associated with the concept. So in this case, we have 3 terms in the equation. This is the first term, second term, and this is the third term. We should have to express all those terms to have the log. So keep in mind that having 7, it is the same as 7 times 1. So have it as, and also we should have to transfer the coefficients to be as the power c. So in this case, we'll have it as log 3 of x to the power 6, and the minus c should be log 3 y to the power 2, and which is equal to half 7 times c. Now we'll have log 3 of 3, like that. So in this case, we'll have it as should be log 3 in the x to the power 6 minus it should be log 3 y to the power 2, which is equal to should be log 3 and 3 to the power 7. In this case, it means we'll have to apply the actually division law of indices here. So actually it should be division law of logarithm. That will be given as, you should have it as log 3 of x to the power 6 of y to the power 2, which is the same as, that should be log 3 of 3 to the power 7. What is 3 to the power 7? So what do you think is 3 to the power 7 using calculator? So what is 3 to the power 7? Just have it as 3 to the power 7. That is the same as, that should be 2187. Should be that. Then we are going to antilog both sides. That will be given as x to the power 6 of y to the power 2, which is the same as 2187. Like that. So on that point, So on that point, having cross multiplication, have it as x to the power 6. Let me use another key. Now have it as x to the power 6, and which is equal to, should be 2187 y to the power 2. Now this is regarded as the equation 1. And let's go in the second equation. In the second equation. So how do you think we should have to simplify that? So in the second equation, what we have is something about, we have it as, we have to express that as log, should be the way we did with the first equation. We have it as log 3 of x to the power 2 minus, we have log 3 of y to the power should be 4, which is equal to 9 log 3 of 3. So in that case, it means we have it as should be log 3 of x squared divided by y to the power should be 4, which is the same as should be log 3 of 3 to the power 9. Then unplug both sides, we'll have it as x squared divided by y to the power 4, which is the same as, so what is 3 to the power 9? So what do you think is that one? So 3 to the power 9, that will be given as, should be 19, and that should be 683, like that. So the cross multiplication, that one will be given as, that one will be given as x squared, which is equal to 19,683, and y to the power 4. So that is given as equation number 2, as you can see. Now what we have, those are the simplest or simple equations that now we can solve simultaneously. Now let's use the substitution method in order to solve for those actually equations by the way. So let's use the substitution method that in order to solve for those two equations. So now in this case, we should have to make, let's say, x in the second equation as the subject of the formula. So it means we have it as x being given as the square root of, square of, and that should be 9683, and y to the power 4, like that. So keep in mind that, and of course this is the same as having it as, the square of 19683, and the times the square of should be y to the power 4. So which is the same as, the square of, so what is the square of 19683? That is the same as 140 point, let's say 3, and the times y to the power 2, which is given as that. That is the value of x. Should be, that is how x can be expressed as. Then we should have to substitute into the equation number 1 for x. So wherever there is x, we're going to substitute for that one in the equation number 1. We'll have it as, 140.3 y to the power 2, and overall to the power 6, which is equal to 21, should be 87 y to the power 2. Then we'll have everything to the power 6. So in this case, we'll have 140.3, and that is to the power 6. That will be given as a very big number. We'll have it as 7.6 times 10 to the power 12. That is a very big number, and the times y to the power 12, that will be equal to, have it as 2187. That is, and the y to the power 2. It should be that. And then we'll have it as this now. So in this case, we'll have to transfer this to this side. That will be given as 7.6 times 10 to the power positive 12 and the minus 2187 y to the power 2. That will be given as L. Then we should have to factor out y to the power 2. That is the common factor. So common factor is y to the power 2. So for that case, it means we'll have it as y to the power 2. That is, we'll have it as 7.6 times 10 to the power 12. And we should have y to the power. We should have this. So we should have y to the power 12 here. So I missed that one. So y to the power 12. And there should be that. So y to the power 12, like that. Then we should have to, equal to 0. Then we should have to factor out y to the power 12. Should be y to the power 2. That's the common factor. So have y to the power 2, times 7.6 times 10 to the power 12, and y to the power 10 minus 2187, and should be is equal to 0. So in this case, we have two factors. We have y to the power 2 is equal to 0, where we'll introduce a square both sides. Square both sides. We'll have y is equal to 0. That is the first value of y. Then we're going to use that one. So in this case, we have 7.6. We have 7.6 times 10 to the power positive 12, times y to the power 10 minus 2187 is equal to 0. So we're going to transfer this to the other side. That will be given as 7.6 times 10 to the power 12 y to the power 10, which is equal to positive 2187. Then I'm going to transfer both sides by that one. That will be given as y to the power 10, is equal to 2187, and divide by 7.6. 7.6 times 10 to the power positive 12. We'll have that and as that. And of course, from there, we'll have it as, y to the power 10 is equal to, we have 2187 divided by 7.6 times 10 to the power positive 12. And this should be that. With the calculator, what is that one? So what do you think you have that? So in this case, we have, and that should be 2187, and which is divided by, that is 7.6 times 10 to the power, and that should be negative 12. This how it will be. So which means we'll have it as, y to the power 10, which is equal to 2.9 times 10 to the power, there should be negative 10, like that. Then we are going to introduce 10th root both sides in order to solve y. So we're going to introduce 10th root both sides. So in this case, we'll have y is equal to, so what is the 10th root of, and that should be that. So what is 10th root of? So the 10th root of that one, will be given as, that should be 0.11. So now we have two values of y. We have the first value, which is given as y is equal to 0, and we have the another value of y, which is given as, that should be 0.11. Then we're going to substitute those values into the second equation in order to have their respective x values, like that. So start with for y is equal to 0. So in this case, in the equation 2, where there's y going to, or actually for equation 2, where there is actually y, we're going to substitute with 0. So have x squared is equal to 1 should be 19683 times 0 to the power 4. That will be given as 0x to the power 2. Introducing squared both sides, or have x is equal to 0. And for actually y is equal to 0.11, and also principle remains the same. Therefore, you conclude that x is equal to, let's say, 0 when y is equal, should be 0, and x is equal to so when y is equal to 0.01. So that's how you can make it possible in that way. How about, let's say, if we have this case, let's say if we have 2 log of, this should be 3 of x, and by the way, it should be log x. Let's say 2 log x of y, and which is equal to 1. That is equation number 1. And we have the another case, which is xy, which is equal to, let's say, 64. So how do you think we should have this? So in this case, we should have to express the first equation to be in its simplest form. So whereby we have it as, log x of y to the power 2, which is equal to, or have log xx. We can have it as that. Then unlock both sides, we'll have y squared is equal to x. So that is equation 1 as we are supposed to have it. And x times y is equal to 64. That is the second equation. And now both equations are in the simplest form. Now we can solve for x as well as the y simultaneously at that point. So how do you think we should have that? So in this case, using the first equation, we already have x as the subject using the substitution method. Then we have to substitute this into the second equation. So have it as, y squared times y, which is equal to 64. That will be given as y to the power 3, which is equal to 64. So in this case, we'll have y to the power 3 is equal to, is it possible to have, that of 63 to have base, actually to have power 3? Is it possible? So 4 to the power 3, that is the same as 64. So in this case, we'll have 4 to the power 3. So since the bases are the same, then the y will be equal to 4. So that is the value of y in that case, like that. Then we're going to substitute this into the first equation. That will be given as, y to the power 2 is equal to x. So in this case, we'll have it as 4 to the power 2 is equal to x. That will be given as x is equal to, should be 16. So that's how you should have to solve that. And how about, let's say, if we have something like this, and we should see how we can make it up. Let's say if we have, should be log 3 of, let's say, 2y minus, should be 3, and plus has to be 2 log, let's say 3 of x, which is equal to 1. And let's say we have, this is the equation number 1. And let's say we have another equation which is given as log 3. And let's say of x. And plus, let's say log 3 of y, which is equal to, let's say, 2. This is equation number 2. So there is need that each and every equation should be expressed in the simplest form. So let's go for the first equation. So in the first equation, we should have to apply the laws of logarithm. This point, since they're adding, it means there will be subtract. It means we're going to use the product. So in this case, we have it as, log 3 of 2y minus 3, and the times we'll have, by the way, let's see, express it first. We'll have log 3 of 2y minus 3, like that, plus log 3 of x squared, since this coefficient has to be brought at that point, and which is equal to, we'll have it as log 3 and 3. So make sure you understand all concepts behind the logarithms. The concept of solving logarithms and the laws of logarithms and some other related stuffs. So in this case, this is the same as having it as log 3, 2 minus 3 times we have x squared, like that, and which is equal to, we'll have log 3 and of 3. So now we are going to untruth both sides, so have it as 2x squared y minus 3x squared. That will be equal to 3. So that is equation number 1. Now how should it go up next? Now the next thing should be simplifying the second equation to be in the simple form. So in that case, this is the same as having it as log 3 of x, plus log 3 actually of y, which is the same as, and that should be log 3 of 3 to the power 2. So using the laws of logarithms here, we'll have log 3 of xy, which is equal to, should be log 3 of 9. Then we have xy, which is equal to 9. So that is the second equation. So this and this solve simultaneously, and appreciate how you can have it. So try to have that. And how about, let's say, if we have this, and you should have to try the following questions on your own, at your own time, and appreciate how you can have it. Let's say if we can have, should be log 2, let's say log 2 of x minus, that should be 14y, that which is equal to 3. And which to have something about, let's say, log 2 of x minus, we have also log 2 of y plus 1, and which is equal to 1. Try to solve those simultaneously as well. And how about, let's say, if we have something about, let's say, log 2 of, let's say, x plus, we have log 2 of y, which is equal to 4, and we have 7x minus y, which is equal to 6. So how should you solve for x as well as y simultaneously for that point? So try to express that one, and also try this one as well. What if we have something about, let's say, we have log, let's say, 2 of x plus 3, that is equal to, we have 2 plus log, let's say, 2 of y, and we have the second equation, which is log 2 of, let's say, x plus y, which is equal to 3. So how do you think we can solve those actual equations simultaneously? You'd also appreciate this as well and see how you can have that. And let's say we have the say we have something like this, and let's say we have it as it should be log 10 of x, and plus we have log 10 of, that should be y is equal to 2, and that of log 10 of x plus, that should be 2 log 10 of y is equal to 4. So how should you have to solve those? And also, what if we have something about, let's say we have log 2 of x, and the minus we have log 2 of y, which is equal to, we have 2. Then we have log 2 of x, and should be of x minus, has to be 2y, which is equal to 3. So how do you think we can solve for those simultaneously? So that's how you start to understand about solving logarithmic equations simultaneously. Thank you.